Can an engine run without oil and not destroy itself in seconds? For decades, mechanics, truck drivers, and industrial operators repeated the same story. There was an engine capable of continuing to run even when the lubrication system failed completely. It wasn't a secret prototype or a laboratory experiment. It was a real engine, mass-produced, used in trucks, ships, generators, military tanks, and heavy machinery all over the world. Its name was the Detroit Diesel Series 71, and its reputation wasn't built on being quiet or refined, but on something far more unsettling: its ability to survive where other engines simply died. To understand why this engine earned that reputation, we have to start with its design. The Detroit was not a conventional engine. It was a two-stroke diesel, already uncommon in heavy applications, and it used a lubrication and combustion system that made it radically different. In a traditional four-stroke diesel engine, oil is the barrier between life and destruction. Without lubrication, bearings melt, pistons seize, and the engine destroys itself in seconds. In the Series 71, that line was far more blurred. This engine was designed to work under extreme conditions, not for comfort, but for continuous operation, constant loads, and hostile environments. Its architecture included relatively wide internal tolerances, extremely robust materials, and an operating principle that indirectly gave an unexpected advantage when oil disappeared. Being a two-stroke, the engine required a constant flow of forced air through a blower, even at idle. That air not only fed combustion, it also helped dissipate heat continuously, reducing how quickly components reach critical temperatures. But the real secret lay in how the engine interacted with fuel. In many documented cases, when a lubrication system failed, the Detroit diesel continued receiving large amounts of diesel fuel. That fuel, not fully burned along the cylinder walls, began to serve a secondary function, partially lubricating the pistons and liners. It wasn't proper or safe lubrication, but was enough to delay immediate collapse. While other engines seized almost instantly, this one kept running, rough, loud on the edge, but running. This gave rise to stories that today sound exaggerated, but have a real basis. Series 71 engines that continued operating for minutes, and sometimes longer, after losing oil pressure, not because they were indestructible, but because their design allowed them to endure a prolonged mechanical agony. And it's important to clarify something here. Running without oil does not mean surviving without consequences. Many of these engines ended up with severe wear, scored pistons, damaged bearings, and scratch liners. But the key point is that they did not self-destruct immediately, something unthinkable in most modern engines. This extreme toughness was no accident. Detroit Diesel designed the Series 71 with war, industry, and heavy continuous work in mind. Engines that had to start every time, run every time, and keep operating even when something went wrong. That's why they were so popular in military applications, vessels, and equipment where stopping was not an option. The distinctive, sharp, metallic sound of these engines became an audible signature of hard work. However, that same reputation also created a dangerous myth. Many people interpreted the idea that a Detroit Diesel 71 could run without oil as if it were something normal, almost an exploitable virtue. And it wasn't. It ran without oil only because it was dying slowly. It was resistance, not immunity. Over time, automotive engineering evolved toward engines that were more efficient, quieter, and more precise, but also far more dependent on perfectly functioning systems. Modern engines do not tolerate mistakes. The Series 71 did, but it paid the price later. This engine is remembered as a mechanical legend.